Ever feel like you're missing a piece of the puzzle?
Hmm.
Well, today we've got a fascinating fragment from the deep past, one that might just, you know, reshape how you see the dinosaur world.
Ah, okay.
We're diving headfirst into the story of Anaxosaurus darwini.
Right. Aniksosaurus. Yeah, we've been looking through the scientific literature for this one. The
Exactly.
descriptions, the classifications, all the analyses. We want to bring you the most compelling stuff about this creature.
And our goal, it's really to go beyond just the facts and figures. We want to understand what made Anaxosaurus unique.
Yeah.
What secrets can this, well, relatively unassuming dinosaur unlock about life back then in the late Cretaceous?
Good question.
Okay, let's start with the name. Even
Yeah.
that has a story, right? Anaxosaurus. It means spring lizard, which is kind of poetic.
It is, yeah. And the reason is actually quite literal.
Oh.
It was discovered on September 21st, 1995. And, down there, that's the start of spring in the southern hemisphere.
Ah, okay. So a direct link.
Exactly. A nice connection between the find and, the season of renewal.
And the Darwini part. That seems obvious, but
Well, yeah, it's a direct tribute to Charles Darwin,
of course.
his work, his explorations in Patagonia during the Beagle Voyage. It's a real nod to the history of science in that region.
That's great. So where exactly in Patagonia did this spring lizard turn up?
Chubut province in Argentina. It was found within a geological unit called the Bajo Boreal Formation.
Okay, Bajo Boreal. And how old is that?
That layer dates back to the Cenomanian and Turonian stages.
Right, late Cretaceous.
Yep, late Cretaceous. So we're talking somewhere between maybe 96 and 91 million years ago.
Wow.
Yeah.
Imagine that world.
A very different place.
Absolutely.
What?
And who were the researchers who formally described it, put it on the map, so to speak?
That would be Ruben Dario Martinez and Fernando Emilio Novas. They published the formal scientific description in 2006.
2006. Okay.
Although the name itself had kind of been floating around in papers a bit before that formal publication.
Ah,
But their work really laid the groundwork for, everything we know.
got it. So we have the name, the time, the place, the people. What did this Anaxosaurus actually look like? What were its physical characteristics?
Well, our first real look came from the holotype specimen. That's the main example used for the description.
And what was it?
It was a remarkably complete articulated right hind limb.
Articulated, so still joined together.
Exactly. The femur, fibula, tibia, even the foot bones, all still connected pretty much as they were in life.
That's lucky. What were the measurements like?
The longest femur found measured about 247 millimeters.
Okay, that's huge.
And the tibia, the lower leg bone, was actually a bit longer, around 270 millimeters on average.
Ah, now that sounds significant. The tibia being longer than the femur. What does that usually tell us?
That's a classic sign. It's a strong indicator of what we call cursorial habits,
Cursorial, meaning?
adapted for running.
Right.
A longer lower leg bone gives you more leverage, a longer stride.
Yeah.
It's all about speed and agility.
So you can picture it being pretty quick on its feet.
Definitely. Darting around, maybe chasing small prey, or just as likely, avoiding becoming prey itself. You needed to be fast back then.
Makes sense.
Hmm.
So, a runner. What about its overall size then? How big are we picturing this thing?
Well, the early estimates put it at around 2 meters long, maybe 70 centimeters tall at the hip. Weight-wise, maybe up to 65 kilograms.
Okay, so mid-sized.
But more recent studies have tweaked those numbers a bit.
Oh.
Yeah, the thinking now is maybe a little longer, perhaps 2 to 3 meters, but actually lighter. Maybe more like 35 to 45 kilograms.
Interesting. So leaner, maybe?
Yeah.
Still a decent-sized sprinter for its time?
Pretty much.
Now, bones don't just tell us size and shape, do they? They can tell us about growth, too.
Absolutely. Bone histology, looking inside the bone structure.
And what did that reveal for Anaxosaurus?
Well, this is really fascinating. A study back in 2013 looked at the microstructure of the bones,
Uh-huh.
and the results suggested that the holotype specimen and others found with it weren't actually fully grown adults.
No kidding. They were younger.
Yeah, juvenile to subadults, still growing.
How can you tell that just from looking at bone under a microscope?
There are several clues. For instance, they lacked something called an outer circumferential layer, which usually forms when bone growth stops or slows way down in adults.
Okay.
And they didn't have many secondary osteons. Those are like remodeled bits of bone that build up over time in mature animals.
I see.
Plus, you can sometimes see growth cycles like rings in a tree, and these individuals only showed a few. The thickness of the bone zones also pointed to ongoing growth.
So how old were they, roughly?
The estimate from that study was around 3 years old.
3 years old. So the picture we have might mostly be of, like, a teenage dinosaur, still in a growth spurt.
Exactly. It definitely adds a layer to how we interpret the fossils.
It really does.
Yeah.
Okay, so where does this potentially teenage sprinter fit in the grand scheme of things? The dinosaur family tree, how's it classified?
Right, classification. Well, initially, Martinez and Novas looked at the hind limb anatomy.
The part they had the most of.
Precisely. And based on that, they placed it within Coelurosauria.
Coelurosauurs. That's a huge group, isn't it? Lots of bird-like theropods?
A very large and diverse group, yes. They saw it as more derived, more evolutionarily advanced than some early coelurosaurs like Compsognathus or Ornitholestes,
Okay.
but less advanced than the later really famous ones like Tyrannosaurus or the Oviraptors.
So somewhere in the middle of that big coelurosaur brain.
That was the initial idea, yeah.
Yeah.
And there were specific features supporting it.
Such as?
Things like a well-developed fossa, a depression on the ilium called the Capitecus fossa, also features on the femur, like a forward-projecting bit called the anterior trochanter, a broad greater trochanter.
Okay, technical details of the hip and thigh bones.
Right. In a rectangular shape to the top of the femur from the front, and a slender fibula, the smaller lower leg bone, all pointed towards Coelurosauria.
But you said initial idea. Paleontological plot twist coming.
Ah, you know it. As often happens, later studies came along.
With new data. Or new ways of looking at it.
Both, really.
Right.
Looking at different features, using different analytical methods, and they started suggesting different spots for Aniksosaurus.
Like where?
Well, in 2010, one analysis suggested it might actually be closer to Compsognathidae.
Compsognathids. Those little guys.
Generally small and lightly built, yes. Then, a 2019 study placed it as a Maniraptoromorph.
Okay, another big group.
Right, includes Compsognathids and the really bird-like Maniraptorans, but this study put Aniksosaurus sort of on its own branch, outside both of those.
Still not settling down.
Not yet. And then, most recently, in 2022, a paper even proposed it could be a Megaraptoran.
Megaraptoran. Wow, those are the ones with the big hand claws, right? Their relationships are debated too, aren't they?
Exactly. Big predators, and yes, their own spot on the tree is still fuzzy. So putting Aniksosaurus there adds another layer of complexity.
So its exact family ties are still very much an open question.
Yeah.
A dinosaurian identity crisis.
That sums it up pretty well. It really shows how dynamic paleontology is. You find new fossils, you develop new ways to compare them, and the picture keeps shifting.
It's science in action.
Yeah.
Even with decent bones, the interpretation evolves. Okay, beyond those general coelurosaur features, were there specific anatomical traits that really screamed Aniksosaurus, the diagnostic features?
Yes, Martinez and Nogos listed several unique things. For example, the vertebrae in the neck near the skull. Their neural arches, the top part, were really deep vertically, and they had paired hollows or cavities on their front surfaces.
Interesting. Neck details.
And it also had a surprisingly wide neural canal running through the vertebrae.
Where the spinal cord goes.
Right. What else? Oh, the front tail vertebrae had a distinct ridge underneath, a keel, and the side projections, the transverse processes, were triangular when you look down on them.
Okay.
And even though the main find was the leg, the description mentions robust hand claws, ungual phalanges.
Strong hands, even if we haven't found much of them yet.
Seems like it. And back to the foot, the metatarsal and the fourth toe bone were distinctly narrow side to side.
A specific list of traits. Anything else that stands out anatomically?
One more really key thing, the ilium, that big hip bone. It had an extremely expanded shelf on it called the brevis shelf.
Brevis shelf, what's that for?
Muscle attachment, specifically for powerful tail muscles.
Ah, so maybe a strong, muscular tail.
That's the implication. Could be important for balance, especially if it was running fast.
Makes sense. And one last thing.
Yeah, the femur had a deep notch for another muscle, the M. iliotrochantericus, also involved in leg movement. Lots of clues in the muscle attachment points.
So putting all those subtle bone features together is how you identify this particular dinosaur.
Okay, let's shift gears slightly. The sources mention something really intriguing social behavior.
Yes, this is a cool part of the story. The main evidence comes from finding what we call monospecific bone beds.
Monospecific, meaning just one species. Exactly. Fossil sites where the vast majority of remains belong to just one type of animal. In this case, Multiple Aniksosaurus individuals were found together in the Bajo Barrel Formation.
So finding a group of them fossilized together suggests they lived together.
It's strong evidence, yeah. It suggests gregarious behavior. They might have lived in groups, maybe died together, like finding a snapshot of a prehistoric group.
Why would they group up?
Could be several advantages. Better protection against predators, maybe cooperative foraging, though we don't have direct proof of hunting together. But safety in numbers is a big one.
And the way they were found supports this.
Yes. The taphonomic association, how the bones were associated in the rock, and the bone histology we talked about earlier, both seem to support these individuals living closely together.
Wow. Are there other dinosaurs where we see similar evidence?
Oh, yes. The source mentions a few classic examples, often interpreted as gregarious based on bone beds, like Coelophysis barry from the Triassic, Syntarsis rhodiensis, the Tyrannosaur albertosaurus sarcophagus, and the Ornithomin Sinornithomimus donji. Similar finds, similar interpretations.
Interesting parallels. And the source also hints this social grouping in Aniksosaurus might have been age-specific.
That's right. The evidence, particularly the age estimates from the histology.
The 3-year-olds?
Exactly. It suggests this gregariousness might have been most common during their subadult phase.
So maybe younger ones banded together for safety before striking out on their own as adults.
That's a plausible hypothesis, like a teenage dinosaur pack roaming around.
Teenage dinosaur pack. I like that. Okay, so we've got potentially social, fast-running, possibly teenage dinosaurs. What was their world like? The environment?
Well, the Bajo Formation, where they lived during the Cenomanian Turonian, it wasn't just Aniksosaurus there.
Who else was around?
We find fossils of the eblosaurid Xenotarsosaurus, various sauropods like Drusillosaura, Apactosaurus, Campylodonus.
Wow, big neighbors.
Definitely. Also, the Hadrosaurus caesurnosaurus, and teeth from big Carcharodontosaurids and smaller Dromaeosaurids, the Raptor types.
A diverse crowd. What do the rocks themselves say about the landscape?
The sediments, the way they're layered, they suggest a low-energy, fluvial, floodplain environment.
Fluvial.
So river-related.
Exactly. Think of a river system, maybe meandering, periodically flooding its banks and depositing sediment across a fairly flat area nearby, an overbank setting.
Okay.
And the presence of sandstone layers with coarse sand and bits of volcanic tuff mixed in reinforces that picture of a river system shaping the landscape.
So living alongside rivers, not necessarily out on wide open plains.
Got it. Now, taphonomy, how the fossils formed. What clues do we have there?
The Aniksosaurus bones actually tell quite a story about what happened after death.
Oh.
There's evidence of subaerial weathering.
Meaning they were exposed to the air for a while.
Yes, before burial. And there are even little grooves on one femur that look like marks from scavenging.
Scavenging? By what?
Probably small vertebrates, little nibbles.
Okay, what else?
The skeletons weren't found perfectly articulated either. They show partial disarticulation.
So the bones got separated somewhat.
Right. Maybe starting to decompose, or maybe currents moving them around. It seems likely river currents did reorient the remains after they started to separate.
And the burial itself?
It looks like it happened in stages, at least 2 different episodes of sediment covering the bones. Differential burial.
So, a complex process after death. Anything ruled out?
Interestingly, the study notes no clear evidence for things like cannibalism or injuries from fighting each other, nothing to suggest that intense competition led directly to this particular bone bed.
Fascinating. Exposure, scavenging, currents, burial in stages.
Yeah.
Quite the journey to become a fossil. Okay, let's try and pull this all together. What are the key things you think our listeners should take away from this deep dive into Aniksosaurus?
Well, I think first it's a dinosaur with a really cool name story tied to spring and Darwin.
Definitely memorable.
It hails from Patagonia, late Cretaceous. Physically, the big takeaway is the adaptation for running, that long lower leg.
The sprinter aspect.
Right. Then there's the intriguing evidence for social behavior, possibly concentrated in younger, subadult animals.
The teenage pack idea.
Yeah. And maybe most importantly for understanding paleontology, its classification is still debated. It really highlights how science refines its understanding over time. It's not static.
Absolutely.
Yeah.
It shows how our knowledge grows and changes. Even with fossils we think we know, new studies can offer fresh perspectives, maybe more complicated pictures. Aniksosaurus is a perfect example of that process.
It really is. And maybe a final thought for you, the listener, to ponder.
Okay.
Think about how that environment, the riverside floodplain in Patagonia, and the potential need for speed or group living, how might those factors have intertwined? How did they shape the life and evolution of this specific dinosaur?
Environment driving behavior, behavior influencing survival.
Exactly. And it makes you wonder what other stories are still locked away in those Patagonian rocks just waiting for the next discovery.